Jai Jirendra, Namaste and welcome to my channel. Today we are going to solve the 101st question of the problem solving series and the 11th question of the topic tree. The difficulty level for this question is medium and this question has been asked in Meta, Google, Amazon, Microsoft, LinkedIn, Adobe and many other companies. It's a very popular question. We need to find the diameter of binary tree. So we are given a binary tree. Let's look at this example. 1, 2, 3, 4, 5. We need to find the diameter of it. So what is diameter? Diameter is the largest distance between any two nodes in this binary tree. So that largest distance we need to return. That is the diameter of this binary tree. So for example, if you see the distance between this one and this one, this node and this node, what is the distance? The distance is 1, 2, 3. Right? So we have to move 3 times, right? 1, 2, 3 to reach this node. So this the largest distance between is this the diameter of the binary tree? Do we have anything more whose distance is more? Say if you take the example of this one, 2 and 5, what is the distance? 1. 1 and 5, what is the distance? 2. So from 4 and 3, the distance is the largest distance. So we return 3. Now how do we solve this? So we have solved the problem height of the binary tree. So where we recursively found what is the height from the root, the distance from the root to the node we are finding. But here in this case, it is not, we are not finding it from the root. It could be any node. It could pass from the root. It also may not pass from the root. Okay, suppose there were like 15 elements here. So in that case, the maximum distance, and here for 14 elements. So the maximum distance would not pass from the root. It would be like the 14th element here and the 15th here, right? So there is a curve between the nodes, right? So how do we solve this? What are the observations? So every time you need to observe few things, make some observations, and with those observations, your code should apply those observations and solve the problem, right? So what do we see here? We know how to find the height of the binary tree. So that means from the root to the leaf, or like maximum distance any node, we need to find, we know how to find that. Can we use that height of the binary tree to which can help us to find the diameter of the binary tree? Like if we find the distance from one node to every node, once we find the distance, we'll be able to know, okay, this node has the highest distance, like maximum, finding maximum number from in an array. Same logic we can apply. So suppose if we find the height of the binary tree from this one, from this root node, okay, so we would know what is the highest distance from this node to any node. Okay, now once we know that, so for any node, what is the highest distance from this one? But the node may not pass from here, right? So we can go to the left and find the highest distance. Okay, in this node, what would be the highest distance, right? So we can do the same for this node also. But then also it could be that the nodes are here and here in two different places. So what we can do, if we find the left height from here in the root, we find the what is the height of the left subtree and the height of the right subtree. What would be the maximum height if we add that from here? Then we will get the diameter of the binary tree, because that would make the diameter of the binary tree. From here there is a distance, from here there is a distance. So obviously this distance will be more from the root, right? So we understood that from the root, whenever we are traversing the tree, if we find the left height and if we find the right height and we sum it, so that is the distance. Like here, 4 and 3. If you would have find the left height of this, 4 is at the below, so this is 2, right? And this height is 1. So 2 plus 1, 3, right? So for every node we can do this. We know how to find. We will use that height, find the height of. If you have not seen the video, or if you don't know how to find the height of the binary tree, do watch that video. So we can use that logic to find the height of the left subtree and the right subtree. So we will get an answer that passes from this diameter, this node. Then we can move to the left node and right node and we can find it. And we can see if that from here, for this left height and for this right height, is that sum is more than this or not. If it is more, then we will replace it, right? We'll have that maximum value from this one. We'll take that one. If it is more, then we'll replace that. So that way we can find. So we'll be able to solve this question in this way. But will it be an optimal solution? What would be the time complexity for that? So we know the time complexity for finding the height of the binary tree is order of n, right? You go to the leaf node, you traverse everywhere and you find out the height, okay? So for this one you are finding the height. In the worst case, that would be the order of n. Again you will be doing it for this one. So again we will do it for all the nodes. So it would be n into n. So the time complexity would be n square, which is more. We can optimize it, but how do we optimize this? Now we found, should I write this code? I don't think I need to write this code. I'll write the original code directly. You can try whatever logic I have said. You can try, but if you want me to, So what we can do here? We'll call a function. Let's not write the code, the brute force code. I'll write the optimal code, and from that only you can understand how the brute force was done. So hold on. So now here we are finding the height of the left. So the formula is the diameter is actually max of diameter plus left height plus right height of the tree, right? This is the thing. We'll find the left height from the height formula, node left. We'll find the right height, node right, and then we will get this. Okay. Now we have order of n square. How to optimize it to order of n or any lower time complexity order is that when we are finding the height of the left subtree for this one, I need to find it for this one again, because this already finds the left height for this one, right? Did you get my point? So suppose I am finding the left height for this root node. I am passing this node left. Okay, I am finding this left height. Suppose it is 2. Okay, this height is left height is 2. 1, 2 nodes. Now once I have found this, so if I go here, why do I need to find the left height for this one again? We know I have gone here, so the left height will be reduced by 1. We have already found it. So finding it again is a repetitive task, right? Redundant task. So can we use the same height I can find the height once? Can that function, will that be help us to find the diameter of the binary tree? Because I know the height for this one left. I'll be able to get the left height for this one as well, right? It would decrease by 1. And this one I would know, right? Because for this, when I need to find the left height for this one, I would have computed it for this one. So with the bottom up approach, I'll be able to know the height everywhere. And I'll use this logic when I am finding the height of the binary tree, and I'll get the diameter just by using the height function itself. I'll code it and then you'll understand. I take int diameter equal to 0. Okay, and then I call the function height. I pass root, okay, and I pass diameter. Okay, just the height function, and then I will return diameter. Now how this height function will help us to find diameter? Let's see. Now I'll code this height function. Int height tree node is strict root, and I am passing int diameter. Okay. Now if root is equal to null, that in that case the diameter will be 0. Just return 0. Otherwise, what do I do? I find the left height, else, okay, don't need to write else here, I am returning automatically, it will come here. Int left height is equal to, what would be the left height? We know the left height would be height of root left. Fine. What would be the right height? Int right height is equal to height of, okay, we pass the diameter also, diameter. Okay, here height would be root right, diameter. Okay, now what do we do to find the height? We just return 1 plus max of LH and RH. This returns the height of the binary tree. But where is the diameter logic? Now you understand. What we do, we know the diameter formula is this, the left height plus right height. So here, once I call this function, height of root left, recursively, it will find the final height. Okay. So this height LH would find the final height of this one, which is 2. RH will find the height 1. We have already seen how it does. So we have left height and we have right height. So what is the actual height of the binary tree? The actual height becomes node root plus whatever is the left height and right height maximum value. That is the height of the binary tree. Okay, so we'll be able to find the height of the binary tree, which will be the maximum distance from the root. But what is the diameter? Diameter would be equal to max of diameter comma LH plus RH. Here we will add, instead of finding the max, because the left height and the right height, that is the sum of that. And if we have the diameter, if the diameter, when I call this height logic again, when the diameter will be passed, so for this one, the left and the right sum could be more than this one, right? So if that is the case, then this diameter would replace it, right? And then we will return this. No problem, we return this, we find the height, actual height would go, we'll find the height. Okay, say if I'm calling this, right? So you can say int h is equal to height, but who cares? I don't want to return h, I am interested with diameter. I have passed it as a reference. I'll have the diameter value and then I'll return it and I'll get the diameter of the binary tree. Okay, I hope you've understood this question. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough session. Also, the time complexity for this is order of n, right? Because this is the optimized solution. In the previous the brute force solution, what we did, we would have find the height of the left, height of the right, and then we would have done this thing, right? Twice you used to find for every node you have to find. Here I just replaced it for finding this internally, automatically it finds for all the other nodes. So this is the time complexity and the most optimal. This is the most optimal approach for finding the diameter of the binary tree, whose time complexity is order of n. Walkthrough of the 101st question of the problem solving series and the 11th question of the topic tree, diameter of the binary tree in the LeetCode platform. Okay, you can see this example. This is the same example. This is the same code. So we have already discussed this. You can check the code and I'll just submit this. So you can see it has passed. You can see the companies that have asked these questions. A lot of companies have asked this question, and the time complexity, as we discussed, is the optimal approach. The time complexity is order of n. See you also in the next video where I'll be explaining the 102nd question of the problem solving series and the 12th question of the topic tree. Jai Jinendra.